Hello class, and welcome to lesson 2.4, transformations of sinusoidal functions. So over the last couple of lessons, we've been dealing with the translations, which was your movement based on D and C, so it either shifted left or right or up or down. And then last lesson, we talked about the compressions, stretches, and reflections, and that was based on A and K. Today, we're going to put it all together. So let's just review quickly what we should already know about sinusoidal functions. So just remember, folks, we could have a transformation based on either the cosine function or the sine function. One thing to remember back from grade 10 or 11, grade 11, is to factor out k. What I mean by that is, say I gave you an initial example, for example, y equals 3 cos 2x minus 90 degrees minus 1. Looking at this, folks, what is the k value? It is 2, but it is not factored out from the d. So what you need to do is factor that out. So you're going to have 2 times x minus, and d becomes 45. Subtract 1. So you need to remember to always factor out d, just in case it's not factored out already. Okay? And again, that d will affect it. So this affects D if you don't have that done correctly. Okay? So make sure that you take a look to factor that out. Now let's just recap on what we've learned already, ladies and gentlemen. So hopefully most of this is review. A period is based on taking 360 degrees and dividing it by the absolute value of K. Our starting point is D. Okay? And taking a look at your equation of axis, folks, that's y equals whatever your c value is. Your amplitude is the absolute value of a. So when a equals 1, that's what we call normal. Okay. And max and min are things that we touched upon yesterday. So it depends upon your equation of axis where you start, and then you add your amplitude. Whereas your minimum, you take your axis and you subtract the amplitude. Okay, so to get your range, ladies and gentlemen, it's x or y belongs to a set of real numbers such that you have your minimum value is greater than or equal to or less than equal to y, which is less than or equal to your max. Okay, and remember for the domain, folks, it's x belongs to a set of real numbers. That stays standard. So I'm just going to substitute in my new min and max values so that you've got it there. So my minimum is going to be c subtract absolute value of a. Okay, it's got to be less than or equal to y, which is less than or equal to our max, which is c plus the absolute value of a. All right. So there is a quick review of what we're going to do. On the second page, we're going to use all this information to fill in a chart, and then we're going to learn how to put all these factors A, K, D, and C together and to graph it. And we can do this, folks. Don't be scared. We can do it together. All right? Here we go. So to start off with, we've got a chart here of transformations of sinusoidal functions. I think if we break it down into individual parts, it's beneficial before we try to put them all together. All right, so the key things I want to remember, I'm going to write up top. For example, the equation of axis is y equals c. Okay, your maximum value is c plus the absolute value of a, whereas your minimum value is c subtract the absolute value of a. Your period, remember guys, is 360 degrees divided by the absolute value of k. Your starting value, that's your d, and your end value is going to be your d plus your period. Okay? All right, let's take a look at the first example. And this is a parent function, y equals sine x. So many of these things are going to be similar. Okay, so just write down here, it's a parent function. It's one of the two parent functions. And just to remember, guys, that any of these graphs that we've drawn in the last couple classes and any equations here are all transformations from the parent function, either sine x or cosine x. All right? Let's take a look. Equation of axis, ladies and gentlemen. Again, taking a look. C is 0, so it's going to be y equals 0. Taking a look at your maximum. Again, our amplitude is 1 and C equals 0. So C 0 plus 1 is 1, which means our minimum is -1. Our period, K equals 1, so that's just 360 degrees. Our starting value is at 0 degrees because D equals 0. And our end value is you take that your starting value and add your period, so it's going to be 360 degrees. All right, let's take a look at our second example. And we're going to be graphing this one later. So just make special note that we're going to graph that one after. Okay, taking a look at our C value, ladies and gentlemen, there's nothing there, so the equation is y equals 0. Our A value is a half, and our C is 0, so a half plus 0 is 1/2. And take 0 and subtract 1/2, which is going to give you -1/2. Our K value is 1, so that means 360 degrees. Okay, our starting value here, ladies and gentlemen, look at our D value. Our D value is -60 degrees. That's where we're going to start. And then to find out where we end, you take your D value, which is -60, and you add in your period, which is 360. So that's going to equal 300 degrees is where you end. Remember, those are where you drew those boxes the last couple classes. Okay, you're starting to your end. So you show me one cycle. All right. Next one, and this is the tricky one, folks. Take a look at the third one. Look to see if we can factor anything out, i.e. look for the K. Please look and see that the sign needs to be factored out too. So it's going to be x plus 45 degrees minus 3. Okay? So in this case, we do have a C value, which means our axis is now y equals -3. We look at, we have an axis of -3, and we have a value of 1. So our max in this case is going to be -2. So you go 1 up from your axis and 1 down, which is -4. To do our period, K equals 2, so it's going to be 360 divided by 2. So that's going to equal 180 degrees. And looking at our D is -45, so that's our starting point, -45 degrees. And to find out where we end our box, it's -45 degrees plus our period in this case, which is 180 degrees. So we're going to end at 135 degrees. All right, next one. Okay, for the fourth one, we take a look. Can we factor anything out? No, it's fine as it is. So we take a look at what's our C value. It's +1, so y equals 1. Our maximum value, you take A, which is 3, and you add 1, which is 4. And then to find your minimum value, you take your axis, which is 1, and you subtract 3, which is -2. Okay, to find your period in this case, you take 360 degrees and you divide it by 5 in this case, because K is 5, and you have 72 degrees. Okay, taking a look at D, there's no value for D, so that means it's 0 degrees because it's just 5x. There's no x subtract something in the brackets. So to figure out your, if you start at 0 and you go 72 degrees, that means your ending value is going to be at 72 degrees. All right, moving on. Okay. Taking a look at the next one. When we take a look at our C value, it's +2, so y equals 2. All right. Looking at our maximum value, you start at 2, and you need to sorry, my fault, just scratching my head. Going, you start at 2 and your A is 1, so 2 plus 1 is 3. And then you start at 2 and you subtract 1, which is going to give you 1. Okay, 3, to find your period, it's 360 divided by, what's my K value? 1/2, which is going to equal 720. Okay, looking at my D value, it's 30 degrees. And adding those together, I'm going to have 750 degrees is when I'm going to end. All right, almost done, folks. Hopefully this is good practice before we put everything together. All right, so looking at our C value for the second last one, y equals 5. Now be careful here. You want to be, watch this one here, because A is not just 1, it's -1, but when you sub it in, the absolute value or the amplitude is still 1. So your maximum is 6 and your minimum is 4. Again, it's 1 greater and 1 less than, in this case, of that one, okay, of your axis. Okay, taking a look, ladies and gentlemen, our K value is 1, so that means it's 360 degrees. And your start value, D, is 0, so that means 0 degrees. And if you start at 0 degrees, you got to go 360. That means our end value is at 360 degrees. Last question. Here we go. Sorry. Okay. Looking at our C value for the last one, y equals -1. Okay, figuring out our maximum value, you take -1 and you add 1 to it, which means 0, and then you subtract 1, which is -2. Okay, looking at our K value, K is 1, so that means this is 360 degrees. Taking a look at our D value, that's 15 degrees. And adding those two together to get your end value is going to be 375 degrees. All right, so just remember, guys, that when we take a look at drawing our graphs, remember, your cosine generally starts at its max. Okay, and it usually ends at its max unless A is negative. Then it goes min to max. All right. Let's take a look at the sine. The sine starts at its axis and it ends at its axis, meaning to complete one cycle. And it goes up, so it approaches, starts at axis, approaches its max, unless A is negative, which means it reflects the x-axis. And if it does that, then goes down first, as opposed goes to min or down first. All right. So let's graph the examples 2 and 3 together. Okay. I'm just going to rewrite them here. So the second example that we went over is y equals 1/2 cos of x plus 60 degrees. And the third one is the one we had to factor out k. So it's y equals sine of 2 times x plus 45 degrees. Sorry, just let me rewrite that. I forgot my bracket here. Sorry. So 2 times x plus 45 degrees. That's what I missed. Minus 3. All right. So here we go. Just remember for this one, the first one we're going to draw, what do we know? We know that our axis is y equals 0. So that means we're on this axis, right, guys? Okay. We also know that c equals 0 from that, right? Okay. We also notice our amplitude is 1/2. Because A equals 1/2, therefore my amplitude is 1/2. We also know that our starting point is at -60 degrees. Okay. And we know that it ends at 300 to get one cycle, and the period is 360. So normally, ladies and gentlemen, if I had my parent function, I would start right here at my max. Okay, and that was a parent function. However, my parent function, my amplitude isn't 1, it's actually 1/2. Okay, but I have to start 60 degrees lower from that. Okay, so I've got to start 60 degrees lower. So I'm going to start here as my as my approach. So I know that's going to be the start of my box. Okay, and then I need to get to my end value where it comes back up, which is at, we said, 300. So at 300, I need to also be at my maximum, which is 1/2. Okay, so halfway in between there, which is approximately somewhere in here, I need to get to my minimum. Okay, so if I go on the other side around, if I take that and I subtract my period of 360, I'm going to have somewhere in here, and then way over here I'm going to complete. So to draw my graph, okay, so that is my y equals 1/2 cos of x plus 60. All right. My second graph, ladies and gentlemen, I'm just going to do at the bottom here. So I'm just going to rewrite it because I'm running out of room up there. So y equals sine 2 times x plus 45 degrees minus 3. So normally our parent function would be the sine curve. So normally we start at our axis. Okay. So what is our axis here? Our axis is c equals -3. So 1, 2, 3, here's our axis. Okay. And what do we know? Our period is 180, so we have to do them kind of quickly. So there's going to be more transitions than the 360 here, ladies and gentlemen. And so we know k is 2. So if k equals 2, therefore my period, as we already have on our sheet up above, is 180 degrees. That's what's going to make it shorter. My start value is d equals -45 degrees. And we have an amplitude of 1 because a equals 1. So this one's actually, I find, easier to draw than the other one. Okay, so normally I would be starting here, ladies and gentlemen. However, I have to start 45 degrees away from it. Okay, and my amplitude means I have to go up to 1, but I also have to keep my period in mind. Okay, so if I'm starting at -45, I'm ending at 135. Okay, so I'm ending at 135 right here. So basically I'm going to go up and come back down for 1. And then we're just going to follow that same pattern, guys. Up and down and up. Okay, I'm just going to pause for a second, ladies and gentlemen, because my phone's ringing. All right, folks, sorry, I'm back there. I had a phone call. So just to remember, just back it up. Here was my starting point, and here was my ending point. So there's my square. So we're just developing the same kind of transition pattern throughout. Okay, and that's this one. Right. If you wanted to have the box for the first one, I just didn't complete it. Let me try and color code it a bit better. This one is your blue one. So to get from 1 to 1, there's our 360 degrees there for our period. All right. All right. Let's keep moving on. Let's try to see if we can do some more graphs just if we're given the equation without the chart to help break it down. I know we can do it. Here we go. So y equals 4 sine x plus 2. To start with, I'm going to start with, hey, what's my a value? So A equals 1, therefore my amplitude equals 1. So each of these things have a key piece of information. And we may even be stating these before we even graph it, and that's fine. K equals 4. What does that mean? Therefore my period, if you take it, equals 360 divided by 4, which equals 90 degrees. All right, moving along. D equals 0. That means we're going to start at the origin, or start at 0 degrees. Okay, and we're not absolutely starting at the origin because C equals 2, which means instead of starting at the origin, we're moving up 2, right? So that's our axis, y equals 2. So I always like to do a quick little, hey, I've got to have symmetry about my axis when I go. All right, let's see if we can put it together, guys. Where are we going to start? We're starting at 0 degrees and at 2. So we're going to start here. Okay. And then how long does it take us to complete one cycle? 90. So within this, we've got to go up and down. So if I draw my box here, folks, oh, sorry, try to draw it a little bit bigger. You have to go up to an amplitude of 1, back down for that, okay? So try to follow that pattern so that it keeps repeating itself, okay, as best as possible. Try to do this, okay? And we're going to keep doing it on the other side. So I just like to always highlight my axis so I know where I'm coming and where I'm going. All right, there's that graph. Okay, and let's just double check. Have we stated the amplitude? Yes, the amplitude's 1. The range we haven't done yet, and the equation of access we have done. Okay, so to do the range, okay, we know that y belongs to a set of real numbers such that, what's my minimum value here, guys? 1. So 1 has to be less than or equal to y, which is less than or equal to my maximum, which is 3. Good. All right, let's try another one. So looking at this, ladies and gentlemen, we're going to start with what A, K, D, and C are. So A equals -2. What does that tell us? That the amplitude is 2, but it also tells us that it reflects the x-axis, right? So we've got to be careful here. Okay. Any questions there, folks? Okay, so we know our amplitude is 2. We know it reflects the x-axis. Let's take a look at K. K equals 1. Therefore, we have a period of 360 degrees. Okay, let's look at our D. D equals -30 degrees. That means we start at 30 degrees left, right, of where we would normally start. Okay, and the last one is C equals -1. That gives us our axis of y equals -1. Okay, so I'll just highlight the things that we already were asked for. Okay, so I always like to draw in my axis tentatively. Okay, where does it say we need to start? Our starting point is at 30 degrees left. Okay, so around here. And normally we would start at our maximum, but because it reflects the x-axis, we're going to start at our minimum. Okay, and our minimum is down here. So this is where my starting point is going to be, right here. Okay, and when do I end? If you're wanting to know, 360 degrees. So if you take 360 and you subtract 30, you're going to end up at 330 here. So this is going to be my box. So within that, I need to come up to my amplitude. I need to come from my minimum all the way to my maximum to the axis. So halfway through this, So around here, I need to go up to what's called my maximum. Okay, just remember amplitude is 2. So since we started 2 below the axis, we need to have our maximum 2 above the axis. Okay, and just to be symmetrical on the other side, I need to have my minimum there, and my maximum is just about here. And then we're going to draw our nice smooth curve. Okay, and then I'm going to box out my one cycle just so that you know where's your starting, where's your ending. Okay, oopsie, sorry. So again, you use your your AKDC to help you draw your graphs. All right, moving on. Last example, ladies and gentlemen. Okay, let's try this one. So it says to graph and state your transformations. Okay, so again, we identify our letters. So A equals 2. What does that tell us? That means that it's going to be a vertical stretch by 2. It also tells us that the amp equals 2. Sorry, not 6. I don't know where I got that from. So amp equals 2. All right. We know that K equals 1/2. Okay, so that's going to be a horizontal let me just back that up, sorry. Stretch. Sorry, I'm having trouble writing with this pen in this spot. Just let me back it up again. Horizontal stretch by a factor of, remember you got to flip that 1 over absolute value of K, so it's going to be by a stretch of 2. Okay, but what also does that tell us? That also tells us the period. So period equals 360 divided by 1/2. So my period, ladies and gentlemen, equals 720 degrees. That's helpful for when we're drawing this. Okay. D equals 45 degrees. That means we're going to go right 45 degrees as our starting point. And the last one we need to take a look at is C. C equals -1. Let me rewrite that. Sorry, I have no idea what's going on here with my pens. They just seem to be bugging me today. All right, so therefore the axis is y equals -1. What does that mean in terms of transformations? That means we move down 1. Now we've got our transformations. Now we can graph it, okay? So let's start with, first of all, our base function here is cosine. So we're going to start at our maximum. But instead of starting at our maximum, we need to first of all identify our axis. So let's do that first. Okay, and from that, our amplitude is 2. So from that, we're going to start here. However, I'd normally start here. However, I need to shift to start at 45 degrees. Okay, and then it's going to take me, since it's 720 degrees, halfway is going to be kind of over here. So if you are thinking of how do I center that, I put my minimum here, and then my other minimum is going to be here, which is 45 degrees over. So I apologize, it just needs to shift over one more spot here. Okay, so we're like this. And then we're going to draw our smooth curve. Okay, and that didn't end up smooth at the end here. Sorry, let's try to curve that back up. So if we were asked to draw your box, again, we start here, okay, but it would continue on. It's just because the period's long and 720 degrees. You just wouldn't, you'd leave your box open-ended like that. All right. So ladies and gentlemen, try your homework, page 34, 35, questions 3AB, 4AB, 6ABC, 7ABC. I think those are more of the answering questions like amplitude and period and stuff. And then I want you to, one of them maybe try to graph it, but then I want you to try graphing these three other ones here to get some extra practice. Okay? Sorry for the announcement. I just wanted to let you know that, again, if you need some extra help, come see me. Have a great day.